Welcome back. So today we're doing a bit of a deep dive into a really old problem in live production.
Right.
How do you run balanced audio for, I don't know, hundreds of meters without everything falling apart?
Exactly. And our mission here is really for you, the pro audio learner. We're looking at the specs for a fiber solution to see how light is, well, basically solving all these old analog headaches for good.
Okay, so let's get right into the core idea here. This system uses fiber optics to send, broadcast quality audio over distances that copper just can't handle.
And without losing any of that signal purity.
Oh, that's the key.
So what's fascinating here is the quality they're promising. We're talking 16-bit, digitally encoded broadcast quality audio.
Okay, but hold on. I can see people thinking, 16-bit, everything today is 24-bit.
That's the critical question, isn't it? Is 16-bit really enough, especially over these huge distances?
Yeah.
Well, the insight here isn't just about the bit depth, it's about the guarantee of that quality.
The reliability.
That reliability. The sources say this signal is digitally encoded, so it's completely immune to all the EMI and RF noise that just destroys a copper signal over distance.
And it still uses the connectors everyone knows.
Yep, standard 3-pin balanced XLRs. It just slots right into your existing gear.
Now let's talk about scale, because we're looking at one specific model, the Thor F-4A-XLR-B-TxRx. That's a mouthful.
Ha, it is. But the 4A and the B are what's important. It means 4 channels, bi-directional.
So 2 channels in, 2 channels out.
Exactly. Think about that. You can have your main feed going out to a remote stage, and then you get 2 channels coming right back for a talkback or a monitor mix.
All on one cable.
All on a single, tiny fiber. And the product line, it scales from 2 channels all the way up to 32.
This is where it starts to get, honestly, a little mind-bending, the distance.
Oh, yeah.
A good copper snake, you're lucky to get a few hundred feet before you start worrying. This thing. The basic units support 3,000 feet on multi-mode fiber.
And that's the cheaper, shorter range fiber.
Right. With single-mode fiber, it goes up to 20 kilometers.
And that's just the base model. You can get versions that do 40, 80, even 120 kilometers.
Right, it's just staggering. How does it maintain the quality?
Well, the specs tell the story. You got a sample rate locked at 78 kilohertz. The frequency response is a full 10 hertz to 20 kilohertz.
Pretty standard pro audio specs.
Right, but the key is the signal-to-noise ratio. It's greater than 80 dB.
And that 80 dB SNR holds up across the full 20 kilometers.
It holds up. That's the magic of digital over fiber. Contrast that with trying to keep a signal clean over just a few hundred feet of heavy, expensive copper.
No comparison.
And for anyone who's actually setting this stuff up at a concert or in a stadium or for a broadcast, it has to be tough.
It has to just work.
And it does. It's plug and play. The mean time between failures is over 100,000 hours.
Wow.
And the operating temperature range is, well, it's huge. From minus 20 Celsius all the way up to 75 Celsius. It's built for the real world.
So the whole value proposition is basically this. You're swapping out the physical limits of metal for light. You get clean, long-distance audio that isn't affected by distance or interference.
Right. Which leaves us with a final thought for you to chew on.
Okay.
Given that you can now plug a specialized audio mixer into a system that can send a perfect signal 120 kilometers away,
Yeah.
what does that mean for the problems we used to accept as, just part of the job?
Like ground loops and hum.
Exactly. Ground loops, signal loss,
Yeah.
RF interference, all those fundamental limitations of analog. How many of them are now just completely obsolete because we're relying on light?